Good morning, students. Myself, Dr. Eustace Russell, working as an assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So, hereby, today we are going to discuss about the subject called Kinematics and Dynamics of Machinery, that is subject code of MR3451. Already we have discussed the same subject with unit 1 of some topics, introduction topics I gave in the first lecture video. Today we are going to see the remaining syllabus of unit 1. So unit 1, in the last slide we have seen about layout of cams, the basic cam classification, everything we have completed in the part 1 of the unit 1. Today we are going to see about few topics under this, that is slider crank. That is, today we are going to see about kinematic inversions. Under that, this slide that is giving a slider crank mechanism. That is, we can see a slider part is moving from right to left, and the link, that is crank link, that is a driving one, that is the input we are going to give. The connecting rod, that is reciprocates, and it takes the slider to move in the horizontal direction from left to right, otherwise from right to left. Both directions it will take place. So these kinematic inversions can be classified into various inversions, that is first inversion, second inversion. In this first inversion, this inversion is obtained when link 1 is fixed and the links 2 and 4 are made the crank and slider respectively. So I'll repeat once again, the link 1 is fixed and the links 2 and 4 are made the crank and the slider respectively. Few applications are also given in the slide, that is reciprocating engine and the reciprocating compressor. Here we can see how it is reciprocates. In the initial slide also we have seen that 2 is the crank, that is mentioned over here. 3 is the connecting rod. Whenever it slides, what will happen? How the sliding motion is happening? When the input is given in 2, automatically it will give a rotary motion. And the 3 is a reciprocating action, it will give, and finally we will get a sliding motion in point number 4, that is link 4. Second inversion, fixing of the link 2 of a slider crank chain result in the second inversion. That Whitworth quick return motion mechanism and the rotary engine. These are the two varieties we are going to see. Inversion 2, the same thing what I have discussed earlier. 2 is the crank, the 3 is the connecting rod, and the C is the, and that is fourth one is the slider part. Here we can see the Whitworth quick return motion mechanism. This is the motion mechanism. In that crank is the link 3, fixed link is 2. Whenever the driving crank is rotated, what will happen? The slider link for 4 sliding in between the groove, that is in the connecting rod frame. The sliding part is moving here and there. The sliding bar, it will be moving, that slider part. Inside that groove will be arranged. So what will happen? Whenever the slide is, when the crank is rotated, automatically the slider part is moving up and down, the balancing of the rotary motion. Finally the reciprocating motion you will get in the connecting rod, and finally that motion is transmitted to the linear motion to the cutting tool. That is, when it is moving from left to right, it is a cutting stroke, and from right to left it is a return stroke. That is nothing but Whitworth quick return mechanism. And another one at the right hand side of the slide, we can see a rotary engine. It is a GOM engine also, we can tell. But how the mechanism will be utilized? Link 2 is there, one common link. Finally it will be interconnected with multi links. For example, in this how many cylinders we can see means 7 nearly I think 6 cylinders are there. 6 cylinder arrangement. Common one link is fixed to the varieties of links over there, and finally we'll get a rotary motion. When it is moved to that part, some of the various strokes that will be getting. When it is moving to this side, the various strokes that will be obtaining some other engines. So that will be a rotary part. So multi-action will be performed. Third inversion is nothing but fixing the link 3 of the slider crank mechanism, and the third inversion is obtained. Link 2 again act as a crank, and the link 4 oscillates. That is nothing but these are the various applications: oscillating cylinder engine, crank and slotted lever mechanism. In this, what it is clearly given is link 2 will be a crank only. The link 4 is a oscillating motion. Here we can see the middle part of the sketch. We can see that crank is there, that is link 2, piston rod link 1, connecting rod link 3. Finally, what will be happening means whenever the crank is rotated, the sliding motion also will happen. That is, a piston arrangement will move here and there. At the same time, there you will get a oscillating motion of the cylinder will also take place. Oscillating motion of the cylinder will also take place. And in the right hand side of the picture represents the crank and slotted lever mechanism. What you have seen in the previous slide, that is the Whitworth quick return mechanism. The same thing here also we can see that crank is there, that is OB, that is the rotating part, that is will be moving the rotary direction, that is the 360 degree. Slotted lever bar is there. Whenever it is rotated, what will happen means the slider part will move up and down. At the same time, the ram is also connected to the slotted lever bar mechanism. So whenever it is rotated, automatically the slider will be moved up and down in the slotted lever mechanism. So at the same time, the motion will be transmitted to the ram as a cutting stroke operation as well as return stroke operation. When the return stroke will happen means whenever the angle that is happening to the lower side, that is alpha and beta, the two things are clearly given. These two angles, one angle is meant for cutting stroke and another one is for return stroke. Then fourth inversion, if the link 4 of the slider crank mechanism is fixed, the fourth inversion is obtained. The link 3 can oscillate about the fixed pivot B on the link 4. This makes NA of the link 2 to oscillate about B, and the end O to reciprocates along the axis of the fixed link 4. That is, we can see hand pump. Hand pump we can see clearly. Here in the previous slide, this double slider crank. In this we can see the kinematic chain, which consists of two turning pairs and the two sliding pairs, is known as double slider crank chain mechanism. Elliptical trommel. Elliptical trommel is nothing but for drawing a ellipse purpose we can utilize this elliptical trommel mechanism, because we can see one slider is moving in the vertical direction and another one slider it is moving in a horizontal direction. So whenever it is moving up and down, we can combine the major axis of the ellipse. When it is moving from here to here, we can see the horizontal motion, that is a minor axis will be utilized. Minor and the major axis will be get in the ellipse for drawing the ellipse part. Scotch arc mechanism. Scotch arc is nothing but for converting rotary motion into a reciprocating motion. This inversion is obtained by fixing either link 1 or 3. In this figure, link 1 is fixed. We can see link 1 is fixed. Link 2, which corresponds to the crank, rotates about B as sender. Link 4, which corresponds to the frame, that is reciprocating one. Here we can see whenever this crank is rotated, what will happen means At the same time, the slider will be moving up and down, as well as the piston will be reciprocate in the cylinder. That represents spark mechanism. Then old arm coupling. Old arm coupling means we have a groove cutting perpendicular to one another. That is a slotted plate. It is clearly given. It is a slotted plate. In this we are having a link 4 have two straight grooves. Two straight grooves will be there. Automatically, whenever it is moving upward, it is moving in a clockwise direction, two grooves will be balanced. It won't get fell down. Balancing with the horizontal groove as well as vertical groove. That will be get balanced. It's a bar which forms turning first with link 1. So these are the references which I made this slide with the help of these references. So go through this. So thank you all students for your kind attention for this part 2 of unit 1, the subject called kinematics and dynamics of machinery. So I think this video will be very useful for you people. So kindly go through these slides. So in upcoming videos also we will see in the next topics. Thank you students.